Okay, I have started recording.
Welcome to geometry. The lesson plan again is an overview of geometry that includes transformations and special segments. The usual lesson plan will be 10 minutes to go over homework, 30 minutes of the slides, 10 minutes of practice problems in total, and for homework it would be 10 to 30 minutes of questions based on the slides. So first we're going to go over the coordinate plane. There are 4 quadrants. As you can see, it's numbered here. Can you see my mouse moving? Could someone answer if you could see my mouse moving?
Yeah.
Yeah, they can.
Okay, thank you. So yeah, it would be quadrant 1, 2, 3, 4. The horizontal axis would be your x-axis, and your vertical would be your y-axis. And to graph lines, you'd use the equation rise over 1 and the difference of y over the difference of x. And here's an example. And so when you graph these, to find the slope, you'd use rise over run, so you can count these. So it'd be 1, 2, and then you go over, you run 1, 2, 3, 4. So your answer would be 2 or 4. However, when you simplify, it would be 1 over 2. And if you want to do it algebraically, you would do the difference of y over the difference of x. Again, you could subtract 0 minus negative 2 over 4 minus 0. That would be 2 over 4 equals y over 2 if you want to recheck your solution. So next we're going to be learning about graphing inequalities. So the boundary line is dashed for greater than and less than, and solid is for greater than with the line under, and less than with the line under. So dashed line is with no line under the inequality, and solid would be with the line. So again, I'm going to give you another example to preview. And obviously, I'm pretty sure you know how to solve. It'd be mx plus b, m being the slope, b being y-intercept. So that would be the first line. Again, you can see that it's dashed because there's no line under the inequality. And again, the second one would be dashed. And as you can see, the solutions for both inequalities would be the darker shade. Oh, if anyone has questions, you can unmute, but this is simply just going over what you've probably learned over the year and asking questions for clarifications. Next would be graphing parabolas. When you slice this, I'm having a brain fart. When you slice this.
Yeah, so
Yeah.
So if you have a cone, you could slice it at different angles to make 4 different stuff. First, it's called a circle. So I guess most of you guys would know about circles. And then you have ellipses that you would something do in pre-calc. And parabolas. Parabolas are symmetrical, meaning that they have like a line in the center called the axis of symmetry that kind of is like the central line. And then you have hyperbolas, which kind of look like parabolas, but they're slightly different. So yeah, this is a good preview for 4 conic sections, as they are called.
Thank you. I forgot the name for it, this 3D prism. So the parent function of a parabola would be y equals x to square x to the power of 2, sorry. And so this would be your parent function, is usually what you start with. And then when you add other, like when you add in b, or you add in am, which is your just basically different transformations for the parabola, that's going to change your graph. But this is what usually you would start with. So usually you would start with this equation, which is in standard form. To find the vertex, you would use negative b over 2a, negative b over 2a, which is the axis symmetry, and then you would plug that in. That would be x. You plug it in to the equation that you already have, and then you would find y, and that would be your vertex. Your axis symmetry is, again, when you slice it in half, it should be symmetrical on both sides, and that's your x again. So when I talk about transformations, I'm also talking about how the graph looks like, okay? So you see in this equation, a is in front of x, so that it's gonna be the determining factor of whether it's gonna be wide or narrow. And if it's greater than a over here, that's gonna be pointing up. Greater than 0, it'll be pointing up. And if a is less than 0, it's gonna be pointing down, which is a negative. And again, to find the y-intercept, you would obviously plug in 0 into the equation for x, yeah. So the first step of graphing parabola is finding your x-intercepts. Secondly is finding the axis of symmetry, which is negative b over 2a. Thirdly is plug in x, which is the axis of symmetry, into the equation to find your vertex. And lastly is finding the y-intercepts, which is optional, however, like better, it's more accurate for your graph. And you would just plot and then connect those points in order to create the parabola. Anyone have any questions so far? No? Okay. So again, I'm gonna give you an equation. Yeah, this is an example of an equation. So first you would find your x-intercepts, and I would separate this in order to find your x-intercepts. So that'd be x minus 5 times x minus 1, and your x-intercepts would be 5 and 1. And we're gonna find the axis symmetry, negative b over 2a, which would be negative, so sorry, okay, negative times negative 6 over 2 times 1 equals 3. So that'd be your x, and we want to plug x back into the equation to find y, which would be negative 4, which is simple math, so I don't need to go over that, right? And so when you find x and y, that would be your vertex, so it would just be 3 and negative 4, which is right here on the graph. And I just want to make the graph a bit more accurate, so I want to plug in 0 for x in order to find the y-intercept, and the y-intercept would be at 5, so it's 0, 5. And we could just
also, yes, I wanted to point out to people that remember whenever you have a quadratic and they tell you to find the y-intercept, it's always the constant term, okay? It's always a constant term, okay? Yeah.
So next, I'm putting review questions in between the slides in order for you guys to remember and comprehend the lesson a bit more. So right now, I'm gonna give you a few minutes to actually graph this. Again, if anyone wants me to go back to the slides with all the steps, you can say so. I would want you guys to find the x-intercept, the vertex, the y-intercept, axis of symmetry. I will give you guys about 3 minutes. Is that good enough? Okay. I'll stop the timer right now. So, oops. Wow, that was fast. The axis of symmetry would be -1, x equals -1. The vertex, when you plug in the x into the equation, would be -1, -4. The x-intercepts are 3 and -1. And And on the graph, it says that the y-intercept would be -3, like he said, the constant variable at the end right here. Any questions? No? Okay. So next, we'll be talking about circles. The parent function, again, with x to the power 2 plus y to the power 2 equals r to the power 2. So r is basically the radius, which is how far your center is to the outer point. And when we're talking about transformations, the function would be x minus h to the power 2 plus y minus k to the power 2 equals r squared. If it's a positive h, it would be moving to the right. Negative h, it translates to the left. Same with k. However, k, again, because it's on the y-axis, if it's positive, it's going to transfer up, and if it's negative, it's going to translate down. Okay, this is a second review question. Does anyone need an example before we go over the review question? Just take a quick minute. Again, remember the parent function should be x squared plus y squared equals r squared. And if there's no r squared and they already multiplied it for you or squared it for you, then you're gonna square root the r squared, which is 36. I'll give you guys a minute to figure it out. I'm interactive with you guys. So anyone know the answer, they can say it out loud right now. Because 1 minute's already up. Anyone? Take a guess at it. Oh, it's okay. Maybe when you guys are more comfortable. Okay, so the answer is D. Congratulations, you guys got it right. Are there any questions? I'm just gonna go over it. Just a quick overview. So because it's a positive number, x minus, what is it, k? Okay, sorry, let's go back. H, x minus h, that's the parent function. And so because 3 is already a positive, it's gonna translate 3 to the right. Since k is positive, it goes 3 up. And so 36, we're gonna square root that, that's 6. And so that should be the number between the vertex or the central dot and going out. So it'd be 1, 2, 3, 4, 5, 6. Yeah, so D is the answer. Okay, now it's our other tutor that's going to go for translation, rotation, reflection, dilation.
Translation is basically when a graph or another figure moves, or like it shifts to a different set of coordinates. So basically, all of the points, they shift the same number of units in the same direction. So like here, you can see the faded triangle, the lighter one, is basically where the shape started off, and all 3 coordinate points moved upward and to the right. They translated a certain number of units. A rotation is when a graph or another figure revolves around a fixed point or the center. So here in this picture, you can see that where the kind of translucent triangle was, that's where it started, and where the little plus sign is, that's the center of rotation. So it rotated that a certain number of degrees around that plus sign. A reflection is when a graph or another figure mirrors or like flips itself across an axis or line. So if you look at the figures below, the first on the left, it's mirrored over the y-axis, and so it's the same number of units away from the axis, but it just mirrors itself onto the other side. And the one on the right, it's flipped across another line. It's not an axis, but it's a different line that it's reflected over. A dilation is when a graph or a figure changes in size. So it either grows or shrinks, and it's very proportionate. So none of the angles change if it's like a polygon, but the side lengths do change, but they all stay proportionate to each other. Do you have any questions about that? I guess not. Okay. So this is how you transform a function. So when you have the function f of x plus b, you're adding b units to the x value. And since if you looked at the circle formula, it's kind of similar, because when it's x minus h or y minus k, it translates to the right, but when it's x plus b, it translates to the left. So if you see a plus sign, it's to the left. So if you have f of x minus b, it translates the function b units to the right. But if you have f of x and then you add b at the end, then it translates the function b units up. And if it's minus b, it translates the function b units down. But don't get mixed up with your x's and y's, because when you usually associate negative values with left, but in this case, x plus b means right, or x minus b means right, sorry. And if you add a negative to the beginning of the function, you reflect the function over the x-axis. But if you add a negative before the x value of the function, you reflect it over the y-axis. So here's another review question. I'll give you maybe like 4 minutes to do both of them. It shouldn't take too much time. If the graph of the function y equals 2 to the x is reflected over the x-axis, the equation of the reflection is blank, and you were supposed to find out which one it was. And it is C, y equals negative 2 to the x, because if you look back to the table on the previous slide, it said that if you have the negative around the entire function, it's reflected over the x-axis. Anyone have questions?
I'd also like to add, you can also divide, pretend a 1 is in front of the negative, so you can divide that over to y. It could be a negative y, and you know how it is reflected over the x-axis? When it reflects over the y, it's going to change into a positive or negative. It's the opposite of whatever the function is given. So because y is positive here, it's reflecting over the x-axis. And so when you divide the negative over to the y area, it becomes negative y. If anyone needs explaining of that. Okay, so the second question, it's pretty simple. Does anyone want to give it a shot? Just so I know you guys are there. Anyone? It's okay. Okay. Anyway, maybe when you guys are a bit more comfortable. So because it's a positive, again, or x plus 2, it's going to be going to the left. It translates left 2, just because when you find the number that goes into x, in order to make the equation equal to 0, it would be negative 2. So the answer here would be C, or this graph right here. Okay, so we're gonna learn about special segments. This is gonna be a mouthful. So yeah, okay, so the first thing we're gonna learn is about incenter. So incenter is the point of intersection, or the center of the circle, when the circle is inscribed into the triangle, and also the center of angle bisectors. So basically what this is trying to say is when the circle is inscribed, as in you can draw a circle in the triangle given, and it's the center of the circle. And also when you bisect all the triangles, so there'd be 3 bisectors, which is from the point, and then when you cut it in half, these two would be not parallel. I mean, it's symmetrical. Okay, That's in center. And so centroid is a bit different because it's identified by the intersection of three medians. And again, three medians is the line segment joining a vertex to the midpoint of the opposite side, thus bisecting that side. Again, it's bisecting the triangle, however, it makes these two congruent. There we go. It makes both sides congruent wherever it bisects, and there's no circle that's inscribed into the triangle, and that's a centroid. So it's just the center of a triangle that has three medians. And also, in addition to the centroid, there's a rule called the 3/3 rule. The centroid is 3/3 from the vertex to the opposite midpoint. So what that's trying to say, that's a mouthful. So I'm just gonna display it on the diagram. So this is the vertex, right? And so the opposite midpoint is basically kind of the longer side, and this is the midpoint, and it's to the opposite midpoint, which is basically the pointy side, you know. So this should be 3/3 when you find the centroid, and the vertex to the midpoint would be 1/3, and same with all. It should apply to all these lines that make up the centroid. Again, that's another example. If the vertex to the opposite midpoint, that would be 2, which is 2/3, and 1 from the vertex to the midpoint, which is 1, and that is 1/3. So next would be the orthocenter. Does anyone want me to slow down? I'm going to be posting these slides just in case later on, so you guys want to review it. This is a mouthful. So the orthocenter is So the orthocenter is a point where all three altitudes of the triangle intersect. And an altitude is when a line passes through the vertex of the triangle and is perpendicular to the opposite side. And the altitude also makes a right triangle, which is 90 degrees. So there are three triangles which you can find the orthocenter in. There's an acute triangle. The orthocenter, when there is an acute triangle, it's going to lie inside of the triangle. So in here, this is an acute triangle. As you can see, there's 3 acute angles. Orthocenter, it lies in between, and when you the orthocenter is bound by 3 altitudes, again, which are 3 right angles. And when you find the 3 altitudes and the orthocenter, it should be in the middle and inside of an acute triangle. Next would be a right triangle, and it should lie on the right triangle when all 3 altitudes meet at one point, and this is where it is. So again, you're going to draw lines in order to find the 3 altitudes that is perpendicular to the opposite side, which is going to make 3 right triangles again. This is a bit hard. There's a lot going on here, but if you can tell, AB is perpendicular to line BC. AC is perpendicular to line B, which is drawn, which is a right triangle right here. And AC is perpendicular. Whoa. So sorry. Oh, I already gone over that. Yeah, and then BC is perpendicular to line A, and basically just find the 3 altitudes which make 3 right triangles, and wherever the 3 lines meet together is the orthocenter. And let's go back again. So when it's an obtuse triangle, the orthocenter will lie outside. Again, emphasizing that the orthocenter is made up of 3 altitudes, which will create 3 right triangles. In this case, you should be able to draw your own lines to make these right triangles, since the lines aren't given to you, and it's going to lie outside of the obtuse triangle. So the Circumcenter is similar to the Orthocenter because it also applies the acute, right, and obtuse triangles. It has the same rules as Orthocenter. So the definition of a circumcenter is the center of the circle when the circle is circumcised around the triangle, and is also the intersection of perpendicular bisectors. So instead of 3 altitudes, it's going to have 3 perpendicular bisectors. And also, there should be a circle drawn around the triangle instead of in the triangle, like in center. So here, a perpendicular bisector is when a line is drawn through the triangle, and when it bisects, it should have 2 congruent sides. However, it doesn't have to go through any point. It just has to have 2 congruent. It bisects 2 congruent sectors, and it's perpendicular to an opposite side. So it should have 3 right triangles again, right? So again, the acute, it should lie on the inside. Right, it should lie on, so it should lie right here on the right triangle. And obtuse, it should lie outside the triangle. And again, sometimes, or most of the time, you're gonna be able to draw your own lines. And the key thing to remember is just remember all the rules, and especially the acute, right, and obtuse, and where the circumcenter should lie. Any questions about any of these? That was a lot. It's okay. So again, just to review everything, that was the 4 slides I've just went over was a lot. So again, in center, remember that's the triangle where the circle is drawn or inscribed within the triangle, and that's made up of angle bisectors. Next would be centroid. And remember, the centroid is made up of 3 medians, and the orthocenter would be made of 3 altitudes, and also circumcenter would be made up of 3 perpendicular bisectors. And remember that centroid has the 2/3 rule as well. Does anyone have any questions? Remember, again, I want to point out that in center and the circumcenter is different, because the in-center is when the circle is inscribed in the triangle, and circumcenter is when the circle is circumcised around the triangle. So I wanted to point out the difference between those two. Again, the orthocenter and the circumcenter have similar rules regarding the acute, right, and obtuse triangle. Remember that. And centroid, again, the key thing in that certain triangle would be the 2/3 rule. So after all that, I hope you guys retain some information. Tell me if you guys need to go back onto some, but I just want you guys to try these. Actually, let's just try the first question so far, and we can go over that. Does anyone want me to go back to the other slide? You remember, I just wanted to point out that it says in the diagram below of triangle ABC, point H is the intersection of the 3 medians. So just remember which triangle has 3 medians. We can go back. So that's the centroid. And if DH, right here, if DH measures 2.4 centimeters, what's the length of AD? So remember, the centroid has the 2/3 rule, and I just wanted you to keep that in mind. So I'm just going to give you a minute to do that, since I've kind of gone over most of the question. And the next one, you're just going to be doing by yourself. However, I know that I've said a lot, during these past few slides, so I just wanted to make sure if you guys need me to go back, I can. Does anyone want to give it a shot? Like anyone, please. Anyone want to give it a shot? Anyone? Last calls. Okay, it's okay, it's okay. So, like I said, Centroid has the rule of the 2/3 rule. And so the 2/3 rule involves the center to the opposite side of the angle bisector. Yeah. So in this case, because H or DH is 2.4 centimeters, we're gonna multiply that by 2 because AH is 2/3, right? So 2.4 times 2 equals 4.8. However, they're asking for AD, right? So because I already found AH, which is 4.8, we're gonna add that to 2.4 in order to find the whole line, which is AD. 4.8 plus 2.4, 4.8, wow. 2.4 is 12, it'd be 7.2. So it'd be answer C. Any questions? Okay, so next I'm gonna give you about 1 minute in order to do the second problem, and that's gonna be your last problem for today. Okay, 1 minute starts now. Does anyone want me to go back to the other slides? Oh, your 1 minute is up. Do they want to give it a shot? Just a educated guess. Whoops, sorry. Any educated guesses? No? Okay, so we're going to read the question for you. The diagram below shows the construction of the center of the circle circumcised about ABC, triangle ABC. So as you know, when a circle is circumcised around the triangle, we know that that's the circumcenter triangle. Okay, and if we go back to the slides, the circumcenter has 3 perpendicular bisectors. And which answer shows that would be answer D or answer 4. Because when you just pick out the keywords, you don't even need to look at the image. But yeah. And as you can see here, I don't know if you guys wanted me to, I just want to show you guys using the diagram how you could find the answer. As you can see, this would bisect, and there is a right triangle right there. Again, right here, there's a right triangle right here, and where the line that intercepts BC would be a right triangle right here. It'd be 3 perpendicular bisectors. Anyone have any questions? No? Okay, well, you've finished